What if the most powerful climate action you could take was buried right under your feet, and all you needed to unlock it was a ruler, a soil test, and a bit of middle school stoichiometry? This is the quiet, ambitious skill of calculating how much carbon dioxide your garden soil can capture. And it is a learnable blend of science, math, and regenerative gardening. It starts by understanding that soil organic matter, the dark, crumbly stuff that gives Earth its smell, is about 58% carbon. When you increase that organic matter by even a tiny fraction, you are drawing carbon out of the atmosphere and locking it underground. The process is safe, scientifically rigorous, and backed by soil science. To learn this skill, you first observe your own patch of ground. You take a representative soil sample and send it to a lab for organic matter content. While you wait, you measure the area you want to improve. The math is straightforward. You calculate the mass of soil in the top 6 inches, or 15 centimeters, of that area. Multiply area in square meters by depth in meters by the typical bulk density of your soil, often around 1,300 kilograms per cubic meter for a loam. That gives you the total soil mass. Then, a 1 percentage point increase in organic matter means you add 1% of that soil mass as fresh organic matter. Convert that to pure carbon by multiplying by 0.58. Finally, to find the carbon dioxide equivalent, multiply the carbon mass by 3.67, the molecular weight ratio of carbon dioxide to carbon. For example, a 10 square meter garden bed, with a depth of 15 centimeters and a bulk density of 1,300 kilograms per cubic meter, contains about 1,950 kilograms of soil. Raising its organic matter by 1 percentage point adds 19.5 kilograms of organic matter, which holds 11.3 kilograms of carbon. That translates to roughly 41.5 kilograms of carbon dioxide removed from the air. Here is the question that feels like a riddle but is a genuine daily life prompt. If you nudge your garden soil organic matter up by just 1 percentage point across a 10 square meter plot, how many kilograms of carbon dioxide have you effectively drawn down and stored in the ground? The answer, about 41.5 kilos, is equivalent to the emissions from driving a typical gasoline car over 160 kilometers. Once you see that number, your relationship with composting, cover cropping, and no-till practices transforms. You start tracking your soil carbon like a household budget, measuring progress season by season. Learning this skill doesn't require a degree. It requires curiosity and a willingness to pair observation with arithmetic. Beyond your own garden, this personal data feeds into a larger movement of citizen scientists verifying carbon removal. By sharing your methods and results, you help refine models that could shape climate policy. It is a forward-looking act of constructive defiance. You aren't just growing food, you're running a measurable carbon sink. To deepen your learning, compare soil types, test different amendments, and note how much organic matter you can build over a year. Each calculation reinforces your understanding and reveals the power of tiny shifts. In a world hungry for solutions that feel tangible, this blend of dirt and digits offers a genuine, scalable path. It quietly insists that healing the planet can be methodical, precise, and profoundly hopeful. This is not about flashy breakthrough. It is about the quiet accumulation of soil carbon data, a personal ledger of atmospheric healing that sharpens your scientific intuition and deepens your connection to your own land beneath your feet. You begin with a sample, a square meter, and a simple formula. You end with a personal contribution to the global carbon drawdown, measured, verified, and real.